In this lesson, we are going to look at partial fraction with repeated factor denominator. In the previous lesson, we looked at partial fraction with quadratic denominator. I will put a link on the subscription box so that you can see how you can decompose partial fraction with quadratic denominator. Now, for a repeated factor denominator, it can be linear, it can also be a quadratic factor. Now, let's see how we can decompose a linear repeated factor. If we have an expression 3x plus 1 all divided by x times x plus a all squared. Now for us to decompose this fraction, we are going to have the first thing a all over x, taking the first factor, plus b all over x plus a plus c all over x plus a all square. Okay, if we also have this to be a linear repeated factor, denominator x plus a cube, we are going to have this to be a all over x plus a plus b all over x plus a square, now plus c all over x plus a to the exponent of 3. So you notice that first this is reduced by 2, this is reduced by 1, and this is reduced by 0. Now for a quadratic repeated factor, if we have an expression 2x minus 1 all over x squared plus a all squared, this is going to be decomposed into ax plus b all divided by x squared plus a, and this will be plus cx plus c plus d, cx plus d all over x squared plus a all squared. Okay, I know there's a question running through your mind. You'll be asking me, what if this quadratic factor is to the exponent of 3, x squared plus a cube? This will not be a quadratic factor because a quadratic factor must always have 2 roots. So the highest exponent for a repeated quadratic factor will always be 2. Alright, so we cannot have any expressions like x squared plus a to the exponent of 3 or to the exponent of 4. Alright, now let's take an illustrative example. Question 5x plus 4 all over x minus 1 times x plus 2 all squared. Now this fraction can be decomposed into a, that is the constant, all over x minus 1 plus b all over x plus 2 plus c all over x plus 2 all squared. So when we take the denominator of this expression and multiply it by the left hand side, we are going to be left with 5x plus 4 equals to, if you do the same for the term a all over x minus 1 times x minus 1 times x plus 2 all square. You notice that x minus 1 is gone, so we are left with a times x plus 2 all square. The same thing if we do for b. When we work for b, we have it to be b. We are going to have all over x plus 2. So one of the x plus 2 is gone, so we are left with b times x minus 1 times x plus 2. When we also have to do that for the term c, we have it to be c all over x plus 2 all square times the lowest common denominator. We see that this is gone, so basically we are left with c times x minus 1. Let's think of a value of x that would eliminate two of the terms. If I choose x equals to -1, this will be gone and this will be gone. So let's say when x equals to -1, no, +1, sorry, we are going to have here 5 times 1 plus 4 equals to a 1 plus 2 all square plus b into bracket 1 minus 1 times 1 plus 2 plus c into bracket 1 minus 1. When you simplify this, this is going to be 9 equals to, so here will be 3 square, which is 9. Here will be 0, this will be 0. 0 times 3, which is 0. So here will give us 9a. And so it means that the value of a is equals to +1. Let's also think of its value of s that will eliminate some of the thing. So when x equals to -2, we are going to have it to be 5 times -2 plus 4 equals to a into bracket. This will be -2 plus 2. Basically, we are doing substituting the value of s into the expression. So exponent of 2 plus b times -2 minus 1. So -2 minus 1 times -2 plus 2. Here we are going to have plus c into bracket -2 minus 1. So here we are going to have -10 plus 4 equals to, this value here will be 0. -2 plus 2 is 0. 0 squared is also 0. This will be -3 times 0, and this will be -3. So here we are going to have -3c. Then -10 plus 4 will give us -6. So this will be -6 equals to -3c. When solving for c, we are going to have c equals to +2, because that will be -6 divided by -3, which is going to be +2. So the value of a is 1 and that of c is 2. We have found a to be 1 and c to be 2. Now let's go ahead. For us to find the term b and expand this expression, we are going to have 5x plus 4 equals to a into bracket. Okay, this will be x squared plus 4x plus 4 when you expand this expression, plus b into bracket x squared plus 2x minus x minus 2, and here will be plus cx minus c. So here we have 5x plus 4 equals to ax squared plus 4ax plus 4a. Here we have bx squared plus 2bx minus bx. No, sorry. Here, when you say 2x minus x will give us x. So let's just go ahead and work with that. Okay, so this will be bx squared plus bx minus 2b plus cx minus c. Grouping like terms, we're gonna have 5x plus 4 equals 2. So we have here ax squared, bx squared. So this is gonna be a plus b or x squared plus, we also have here 4ax, bx and plus cx. So this will be into bracket 4a plus b plus c times x. And here we have the constant 4a plus 4a plus, sorry, that should be minus 2b minus c. Okay, so let's equate their coefficients. Since we have found the value of a and c, so let's just take the one that will give us the value of b. So from this expansion, we know that a plus b is equals to 0. The coefficient of x squared is not given. Since it's not given, it means that the term x squared there is 0. Now we know a to be positive 1, so we can say that b will be equals to minus 1. That's solving for b. So we have arrived at a equals to 1, c 2, and b equals to minus 1. Now let's try to substitute the value of a, b, c into the given expression. The given expression is 5x plus 4 all divided by x minus 1 times x plus 2 all squared, which was decomposed into the expression a all over x minus 1 plus b all over x plus 2 plus c all over x plus 2 all square. So it means that when we substitute the value of a, b, c, we are going to have 5x plus 4 all divided by x minus 1 times x plus 2 all square to be equals to, the value of a is 1, so this will be 1 all over x minus 1 plus the value of b is minus, okay? So let's say this will be minus 1 over x plus 2, and that of c is positive, so this will be positive 2 all over x plus 2 all square. Okay, so this is how we go about decomposing a linear repeated factor denominator. Now let's try another example with a quadratic repeated factor. So if we have a question 4x squared minus x, sorry, this should be s cubed minus s squared plus 4x plus 2 all divided by x squared plus 1 all squared. So we have to decompose this expression. Recall, for the numerator of a repeated quadratic factor, we have ax plus b all divided by x squared plus 1 plus, this will be cx plus c, sorry, plus d all divided by x squared plus 1 all squared. So when we take this expression here and multiply the left hand side by the lowest common denominator, we are going to have 4x cubed minus x squared plus 4x plus 2 at the left hand side. Now let's see what we are going to have at the right hand side. So ax plus b all divided by x squared plus 1. So this is times s squared plus 1 all squared. So one of this is gone. We are left with 1. So for the term a, we are going to have ax plus b times x squared plus 1 plus, if we take this and multiply by this term, we are just going to have a cs plus d. So what happened here is cx plus d all divided by x squared plus 1 all square times s squared plus 1 all square. So this is gone, this is gone. All right, so that's how we arrive at this term. Expanding this expression, still gonna have 4s cubed minus s squared plus 4x plus 2 equals to ax squared plus, no, this will be ax cubed. So this is ax times ax squared, which is going to give us ax cubed plus, this will be bx squared plus ax plus b plus cx plus d. However, let's just rearrange this expression, okay? So rearranging it, this will be 4x cubed minus x squared plus 4x plus 2 equals to ax cubed plus bx squared plus ax plus cx plus b plus d. Now at this stage, we just have to equate their corresponding coefficient. Now if you look at the left hand side, the coefficient of x cubed is 4, so we can say that a is equals to positive 4. Now the coefficient of the coefficient of x squared is minus 1. Okay, so x squared here has a coefficient of minus 1, so we can say that b is equals to minus 1. Now we also have here to be ax plus cx, so we can say that a plus c is equals to, the coefficient of x here is 4, so this will be 4. Now we know that a is 4, so we can say that the value of c will be 4 minus 4, which is equals to 0. So c here is 0. Now for the constant, we also see that b plus d is equals to positive 2. That is a constant 2. We know the value of b to be minus 1. So we will say that d is equals to, when we take minus 1 here, this is minus 1. When you cross minus 1 to the right hand side, we are going to have 2 plus 1. So this will be 2 plus 1, which is equals to 3. So we can say that the value of a is 4, b is equals to minus 1, c equals to 0, and that of d equals to positive 3. So let's substitute them into the given expression. We are going to have here to be 4x cubed minus x squared plus 4x plus 2, all divided by x squared plus 1 all squared. The value of x is 4, so we are going to have 4x plus, no, that would be minus 1 all divided by x squared plus 1 plus the term c is 0, so 0 times x is 0. And now we are going to have the term d, which is 3 all divided by x squared plus 1 all squared. So this is how we go about decomposing a quadratic repeated factor. Thank you.